Welcome to another video. In this video, I'm going to solve this question, which is question number 2 from 2019 BHSE mathematics paper. Okay. When I see this question, I also get flashback because this was the first question that I didn't know how to solve. And every time I see this paper, I feel like so stupid. Okay. And I also did this back in 2019, so I have also lots of memories. At that time, what I did was I tried to change the sine inverse of 1 minus x squared into tangent, this cosine into tangent, and I tried to use tangent inverse of x plus tangent inverse of y formula to solve this, and unfortunately I didn't get answer and I left at the middle. Okay, I also feel nostalgic. Recently I have looked back this question and I tried to solve once again, and I realized that if I convert the whole of the sine and tangent into cosecant of y, okay, cosecant inverse of this cosecant inverse, then I can actually solve this question and I can indeed prove that x squared plus y squared plus z squared equals to 1 minus 2xyz. Okay, so let's do this in this video. So I will say let sine inverse of 1 minus x squared whole root equals to theta, such that my sine theta is now equal to 1 minus x squared root, right? So this is just O by h, which is divided by 1. If you use this, then my hypotenuse is 1 unit, right? So if you draw a triangle now like this, and if this is my angle theta, then exactly this 1 minus x squared is my opposite and this one is my hypotenuse. And if you use Pythagorean theorem, then you can get adjacent as exactly x. Therefore, I can now write this sine inverse into cosine inverse by using cosine theta equals to adjacent divided by hypotenuse, right? So adjacent is x divided by 1 equals to x. Okay, so it will be now cosine inverse of x equals to theta. And I also have tangent inverse of 1 minus z squared root divided by z equals to phi. If I say that like this, then my tangent phi will be just 1 minus c squared divided by z, and this is just opposite divided by adjacent. So if I write another triangle like this and say this is angle phi, then my 1 minus z square whole square is just opposite, so this is like this root, then this z is adjacent, and if you use Pythagorean theorem, then this hypotenuse is exactly 1. So I can write this also in cosine phi as z divided by 1, right? A by h, which implies that cosine inverse of z equals to phi. Therefore, what I did was I converted this sine inverse of something and tangent inverse of something into cosine inverse of z and cosine inverse of x. Therefore, when I substitute back in my original equation, I will have all these things in cosine inverse of something. Okay, therefore my whole equation will now change to cosine inverse of x plus cosine inverse of y plus cosine inverse of z equals to 180 degrees, which is 180 degrees is pi radians. Okay, now we have to also express this pi in cosine inverse of something, okay, which is inverse trigonometric function. Therefore, from the principal value, we have that, recall, cosine pi equals to -1, right? Principal value of cosine pi is -1, which will imply that cosine inverse of -1 equals to pi. So instead of writing pi, we'll now write cosine inverse of -1. Okay, now by doing this, we will get cosine inverse of x plus cosine inverse of y equals to cosine inverse of -1, right? And I will move this z into other side and it will become minus cosine inverse of z. Okay, now recall that if we have something like this, sum of cosine inverse of x and cosine inverse of y and differences like this, then we have formula that if we have something like cosine inverse of x plus or minus cosine inverse of y will be equal to cosine inverse of xy. Notice here, if we have plus, then we will have minus, and if we have minus, then it will have plus. Then 1 minus x squared 1 minus y squared whole root. Okay, and actually this formula is derived from compound angle formula, which I will make another video by proving how we get this equation. Okay, and this xy should be in the domain less than +1 and greater than -1. Now by using this formula, we'll rewrite this and we'll get cosine inverse of x y. We have plus, so we have to use minus 1 minus x squared times 1 minus y squared, right? Then whole square root equals to cosine inverse of, here we have minus 1 times xy means z, then we have minus, so we have to use plus, then 1 minus -1 squared times 1 minus z squared, here like this, and whole square root, right? Now if you observe very carefully, this one is exactly 0 because see, -1 squared is 1, so 1 minus 1 is 0, and if you multiply this with 0, then this whole thing in this radical sign is 0. So we are left with cosine inverse of -z, right? Therefore, we have now cosine inverse of xy minus 1 minus x squared 1 minus y squared whole square root equals to cosine inverse of -z, right? If you observe carefully, we have here cosine, here also cosine inverse, which means this inside should be equal to this inside, right? Therefore, we can equate this as xy minus 1 minus x squared times 1 minus y squared whole root equals to -z. Okay, now to further simplify, we can just square on both sides. By squaring on both sides, what we will get is, now see here, if this xy be a and this whole radical sign be b, then we are just squaring this a minus b the whole square, right? So recall from algebra that a minus b whole squared will be a squared plus b squared minus 2ab. Okay, so by using this, we will get x squared times y squared plus here 1 minus x squared 1 minus y squared, because here we have squared, so this radical sign will get removed, minus 2xy, this a, then b, our radical sign, x squared y squared and our whole radical, and -z squared is just +z squared, right? Now what we'll get is, now we can multiply this like this to simplify, and we will get x squared y squared plus 1 times 1 is 1 minus y squared minus x squared minus minus plus x squared y squared minus 2xy 1 minus x squared 1 minus y squared root equals to z squared. Okay, now see, if you see carefully in our equation, we have x squared plus y squared plus z squared. So I think we have obtained this here. See here, if you move this x squared and y squared this side, then we are getting x squared plus y squared plus z squared. Okay, so we have here, see, 2x squared y squared minus here 2xy 1 minus x squared times 1 minus y squared whole root plus 1 equals to here, then let's move this, we'll get x squared plus y squared plus z squared. That means we have got one side of the equation. So we have to manipulate this such that this is now our 1 minus 2x y z. Okay, so this is our job now. So if you observe very carefully here, we have that here 2xy is common, right? So we can get 2xy like this, and we have xy minus 1 minus x squared times 1 minus y squared whole root plus 1 equals to x squared plus y squared plus z squared. Okay, now we have to look for this value. Okay, so back in, if you observe very carefully here, this one, see this, we have this value, right? So which is actually xy minus root of 1 minus x squared 1 minus y squared is just this one. When it goes this side, it will become cosine, right? So we have cosine inverse of negative z is equal to xy 1 minus x squared 1 minus y square root, right? So we have note, we have xy minus 1 minus x squared 1 minus y squared whole root is just cosine inverse of z. Okay, which means we can substitute this value here to simplify this, right? So now what is this cosine inverse of z? This is actually cosine inverse of z equals to negative z, and this z lies between 1 and negative 1. Okay, because see here, if I have something like, if z equals to half, okay, then if I have something like this, then I will have cosine inverse of half like this, right? So if I have like this, then what is the value of cosine inverse of half? It is just pi by 3, which is 60 degrees, right? So I have now cosine inverse of 60 degrees, okay, pi by 3, then our value will be just again half, right? So it is like that, and this value should be between positive 1 and negative 1, because these negative 1 and positive 1 are the domain of the cosine, right? So we have that this is actually negative z, right? So this whole thing is just negative z. So we have now finally 2xy negative z plus 1 equals to x squared plus y squared plus z squared, right? And now we have that 1 minus here 2xyz, right, equals to x squared plus y squared plus z squared. With this, we have finally proved that this whole expression is equal to this one by using the cosine and the inverse trigonometric functions and the relations. Successfully done finally, after so much years of struggle. I hope you all have enjoyed this video, and I'll solve more questions like this from the past paper, and I'll see you next video. Bye. Thanks for watching.